All right, guys, welcome back to Within Tolerance. This is episode 71, and we are joined with the man, the myth, the legend himself, Robin Renzetti. So, without further ado, Robin, how did you get into manufacturing? Go back to when you were a kid. We want to hear it all. Tell us all the cool stories. How did you get into metalworking, machining, all of it?
Okay. Uh, both my brothers, 10 and 11 years older than me, both went to trade schools for machining. One went to Thaddeus Stevens in Lancaster here, and one went to Williamson Trade School in Media, Pennsylvania. They had their textbooks from school, and I saw one of those and dove into it, and I couldn't get enough of it. So from I think I might have been 10 then, and just looking through those books, I actually still have that original textbook from back then. Uh, and when I was 12, I got a Unimat, the little Unimat sort of jeweler's lathe kind of multi machine type of thing.
Mhm.
Lusted after one of those for a long time. My brothers were supportive, but they weren't pushing me at all. So this was just a God given inclination and passion for all things mechanical. Uh, so that was 12. So I started machining at 12 and just did everything known to man, slot cars, all kinds of things. You saw the little miniature bicycle parts that I made on there. I was probably 14 when I made those, 15. And then my one brother worked at a really good all around general machine shop. And so as soon as I was old enough to clean chip pans and stuff, uh, I went there and worked in the summers and ended up uh, taking my apprenticeship there. And while I was in my apprenticeship, in the midst of this, when I was 17, I bought my Bridgeport mill, which I still have, and uh, with that, that's when while I was doing my apprenticeship, it was pretty boring. Keep in mind, I was doing everything known to man on machining and basically just eating it up. And I had thoughts of going to trade school where my brother went, uh, but when he went, it was like 3 weeks of solid shop nonstop, and then a week of studies, or maybe it was two and two. But anyhow, you work solid in there. Well, about time when I was thinking of going, they changed it to half days. And I knew enough about machining to say that's a total waste of time. You're not going to get squat done setting up, tearing down, for the next guy. And I just went to work, said, "Fooey, I'll learn more. I'll learn more doing my apprenticeship than I will, going to school." So the work that was there was interesting in one sense, but I always had an interest in precision and also more sophisticated machining. So you see all these neat aerospace parts and things. And remember, this is before CNCs were commonplace. Um, so I've been machining 57 years. So this is way back. We're talking about when I was doing my apprenticeship. And so the helicopter you see also had an interest in radio control. I had a radio control field across from my house when I was younger, and was out there chasing planes every weekend and just being there to watch and see all the neat stuff. So I also loved helicopters, and there were some RC helicopters at that time when I was in about I guess maybe in my 20s or early 20s. So the helicopter parts that you've seen that I showed on there, that was stuff that I designed and built while I was doing my apprenticeship. Um, so I just realized that and this is maybe a point that I'd like to put out there for people, is if you wait for the opportunity to do the type of work you want to do to show up everywhere you work, it may never show up, and you may never get those skills. So more or less, and to this day, if there's a skill I want to do, I will build something that needs that skill and use it as an opportunity to learn it. So that's kind of been my approach all along. So that's what those helicopter parts were. Very intricate, wacky stuff. Some of it's, bordering on watchmaker type stuff. But just a huge learning experience. So I worked at that place for 7 years. Worked there 2 years, um, just clean because I wasn't old enough to actually work in the shop. I had to be 18. So from 16 to 18, I worked there, cleaning up chip pans and your normal cleanup stuff. Then as soon as I was old enough, I started on an apprenticeship and went through that. And that was also one of those being at the right place at the right time things. Uh, I uh, did the first CNC mill that they ever got. I basically twisted their arm. They were kind of old school, and just encouraged them to get a CNC mill, and that was a Bridgeport Boss 5. uh, and I just had a blast on that. I just really had a good time. And so worked there. That was interesting work. Also was basically we did a lot of work for Pepperidge Farm in general, and meaning making automated equipment for making product. And one of the engineers that kind of worked on projects like that actually worked in the shop, meaning he came there and supervised the products like kind of like daily. He kind of took me under his wing and said, "This guy's mine." And we just built all kinds of wacky equipment together. We built machines to fold pastry turnovers. It's a square of dough, and you fold it corner to corner, and it forms that triangle shape. We built a machine that followed the belt in sync, grabbed the corners of the dough with air operated little fingers, folded them over in a diagonal, crimped them, and stayed in sync with the belt. So things like that. And that was where I just got a lot of opportunity to do a lot of engineering. Because he wasn't an engineer, he let me do everything. I mean, I designed it all. Obviously, he had input and guided the direction we were going, but the actual mechanics of it, I got to do myself. And so I would design the parts and build them. So just an incredible experience. Then I worked there for, like I said, 7 years. Guy that came there worked there for a while, tool and die guy, and left. And he called me to one time where he was working and said, "Hey, I got a problem." And some of this we've covered in the Home Shop Machinist podcast, so I'll keep it somewhat more brief in that area. He called me up, had a problem. I ended up going up there. The owner of the company, Bruce Dunnington, he said, "Who's the mystery guy?" And so I ended up meeting him, took my helicopter parts with me as kind of my resume that I still joke about. And he didn't believe that I made them. And then after describing how I machined each individual part, after a while, he said, "Okay, I believe you now," and offered me a job. And that was really where, again, on the ground floor of a company that was getting ready to build diamond rotary dressers. So extremely precise things. They basically are the precision of mass-produced parts. A way of doing precision mass-produced parts. It's a diamond roll that has a contour on it, the shape of the part you want, whether it's a ball bearing race or a turbine blade fir tree or you name it, taps, things like that. The diamond roll actually has the shape that you want the grinding wheel to be in intimate detail. As an example, a ball bearing race diamond roll, the curve that is there for the ball bearing race, the diamond roll has to dress a grinding wheel, and then you grind a coupon, and then you measure that coupon, the steel coupon, and the trueness of radius and also the surface finish typically has to be within a 50 millionths band.
Oh my goodness.
So yeah, not trivial stuff. Now everything isn't that tight, but a lot of things were. So there I was kind of the main mechanical person on those things as far as building machines to do this, programming the CNC lathes to do the ultra precision work. If it didn't work good enough, tear it apart, scrape it in, do whatever was necessary to, make the machines be more accurate. All of the fixturing and things to do this stuff at these levels, how we mount the diamond rolls, all the process things I was involved in. Keep in mind, I wasn't the only person there, but I was deeply involved in a lot of the actual machines that we did and processes we did, how we did all that. So that's where all the precision stuff came from. And it seems like a big jump from going to a general machine shop to there, but keep in mind, while I was in that general machine shop, I was buying the Brown and Sharp electronic indicator that you see me post a lot in my Instagram posts. That's the original one I bought when I was like 20. And had Weber Crow blocks sets that I bought, my master pink granite surface plates. So I was out to do precision work, whether they were going to do it or not. Were there. I just wanted to have those skills. So that whole thing was my main working for Dunnington Company. Bruce Dunnington was the co-inventor of explosively formed synthetic diamond, which is the DuPont style. GE is the high pressure, slow high pressure style, and the DuPont is the explosive style, which produces a polycrystalline diamond. So he was a very, very smart guy, and really, really neat to work for. So I worked there. Also, that's where I got into spindles. He asked me, can you make a spindle? And I said, sure. And so he made spindles for the diamond roll industry, are the spindles that spin the diamond rolls. So obviously, if you have a roll that is going to produce a 50 millionths band on a ball bearing race, the spindles have to run very precisely. Typically, at least 1 micron or less run out, and 20 millionths, half a micron is very typical.
Wow.
So
you just released a video on that, right?
That video I did was kind of all of the details of the the optimum procedures for spindle assembly and things to watch for and all that. I had posted I was going to do my track mill spindle, and a lot of people asked, "Oh, please do a video." And I don't like doing if there's good content out there, I don't want to try to redo it. And so I thought, okay, I'll look. And I was surprised there were no good spindle videos, not in depth. I'm not saying none are good, but there weren't any that really covered a lot of the intimate details that, nerd out on it type of thing. So I did that one, and that video really, that's a shocker. That thing's really, it's still going. It's an 1.5 hour long video, and the average viewing time in general is over 40 minutes, which is pretty astounding. And it's up to 365,000 views now, and the trajectory just keeps going and going. I'm like, whoa. So yeah, that's a real shocker to me, but obviously hit a nerve there with people that wanted to do spindles. So that's where the spindles came from. I worked there for 17 years, and while I was working there, I also was a subcontractor. So a lot of the equipment that we do, I would design it and then go home and build it and get paid as a contractor to build it. So like the best of both worlds.
That's awesome.
Yeah. And so they got ready to move from their location, which was going to be quite a drive for me. And my wife encouraged me to go on my own. And so I said, well, I'm not going to be moving, and I'd like to keep working with you guys, and I just don't want to go that far. So keep in mind, I did a lot of the designing stuff on this, well, all of the designing stuff initially for quite a while on the spindles. So I said, well, I can't afford, to buy, the software and the computer and all that for doing that. So they gave me, while I worked, as long as I was doing work for them, they gave me a computer and the software so that I could still do designs for them as a subcontractor, which was pretty cool. So they have been my main customer through they've been sold and bought and sold various times, still doing the same thing, but they've been my main customer for a long time. And there's good aspects about that and bad aspects. And I'm kind of a weenie as I'm not really the greatest businessman. So keep in mind, since this is kind of fun for me, that's the main thing, which shouldn't be. And the business aspect of it is kind of like, okay, well, as long as I can keep it afloat so I can have fun, that's kind of my mentality. But and I'm serious about this. Listening to your show, both of you, and thinking about the leaps that you take on, buying equipment and all that, and where you're going is very inspiring. It's like, wow, if I wish I would have had more nerve way back instead of being so comfortable with where I was. So I just wanted to say you guys are impressive. Yeah,
Appreciate that.
That's really cool to hear. We appreciate that.
Yeah. Not everybody goes out and starts injection molding and making molds and designing molds and just goes at it and attacks it like you are, Payton.
That's good.
That's impressive. So then I kept I still doing that, and I've had various other customers here and there, but actually lately that other work has been slowing down, and a lot of my Instagram friends have been sending work my way. So it's all just keeps working out, and also working on doing some products. Sooner or later, I'm actually going to make some precision ground stones myself before
Awesome.
the market's saturated.
Yeah.
But I guess if you put a video out showing people how to make them, you get what you asked for. So,
oh goodness. Yeah, when I started looking into them, actually, somebody had said like, "Oh, I think Robin is making some," and then I looked, and I was like, "I don't see them, so I don't think so."
So that's where we are. I have one of the problems is I have more sellable products than I could ever do in a lifetime. And I guess if I was more of a businessman, I'd be looking for partners who would want to license things and all that. And but at first here, I'm just going to have a whack at it myself and transition more into a product-based thing than what I've been doing, and see what happens.
So, Robin, I got a question for you. So, since you stopped working for them in the past, have you just been doing job shop type work yourself through, like you said, word of mouth and a couple companies here and there? Is that just what you've been doing for the past however many years?
Oh no, they're still my customer. I never stopped. I'm just saying, just lately they've slowed down to the point where I could actually even entertain doing other work. Because
but in general, that's just what you've been doing is just job shop work since then.
Well, No, no, they've been my main customer. Now, I mean, it's not really job shop work in the sense that um, most all of it is spindles or in-feed units or the things you've seen me post. It's that type of item. So, in a sense, it's job shop work in that it varies, but it's not job shop work with like I'm, repairing tractors one day and, welding up, racks for somebody the next day. It's pretty much geared towards the higher precision uh, type of work that I've been doing. But they're still my main customer. But it used to be where I was, booked out for months, always just no end in sight of the work. So I couldn't take other work. I was already behind. But now it's slowed down to the point where I can take other work. So that work has never stopped. Uh, but yes, the other work that I'm doing is uh, general job shop work. And you've seen some of that stuff on Instagram.
Okay. I guess I was just asking if, since you're no longer, quote, formally employed, you're doing your own thing since your last
Oh yeah.
employment, I guess.
Oh yeah. Yes, absolutely. I have been a separate company, my own company since they moved. And yes, from that point on, I've actually been self-employed.
Okay. That's what I was getting at. So how long has that been?
Uh, I'm really bad with dates. Somewhere in the 25 to 30 year range.
Oh wow. So you've been doing it a while.
Yeah.
That's really cool.
So I've got to ask a question too. Looking you up, I always do some research ahead of time for our interviews. Is your brother or one of your brothers the one that owns Renzetti, the fishing company?
Yes.
Or okay,
Yep.
because if you search your name, you pop up in one of the you know uh, our story. You're
Yep.
briefly mentioned in there, and I was like, oh, I'm sure that they're probably related because it's still in Pennsylvania and all that. So
Yep. Yeah, that's my brother. Um, actually, I started fly fishing way back. Um, was really woefully disgusted with what was available in fly tying vices, and I designed the basically a drop neck kind of vise where the axis of the shank of the fly rotates concentric when you spin it, so that when you're winding things on, when you're building the fly, it makes it immensely easier. Um, so um, my mill was at my brother's shop, just physically there when when uh, when I was doing that, and he basically started making a business out of that and patented that style of vice. He's made a huge number of improvements and changes, and turned it into a major business. So yeah, that's my brother, and um, yeah.
that's super interesting. And you said that he went to tech school too. So you guys are all
Yep.
machinists, and he just kind of took a good idea and ran with it. It sounds like.
Yep. Yeah, and it makes all different kinds of fly tying tools.
Oh,
And
very cool.
he does a lot of. He ended up getting Citizen screw machines to do those parts, and I think does a fair amount of screw machine work also. As a job shop.
Huh.
Oh, that's super interesting. Wow, how cool. How cool. Well, we can jump into questions because we got, just so all of our listeners know, we got more questions for Robin than we've ever gotten for a guest. So if we don't get your question, it's not because we thought it was bad or anything. It's because we've got to end this at some point. We don't want to take up Robin's night all night. So um, let's see.
Yeah, where do we start?
Oh, I've got one from Andrew Henry over at Henry Holsters that I thought was a good one to start on. He says, if confidence to mod, alter, or hack tools or methods depends on understanding the underlying how and why, how can a self-taught shop owner build the foundation in the mechanical arts that they need to depart from the beaten path when faced with a challenging part or a new process?
Um, I just heard another podcast that I listened to, and they mentioned a guy who said that talking about people in the watchmaking world, and they said confidence is a superpower, and I really resonated with that. There's a confidence doesn't have to be arrogance. Confidence can just be, I know that if I have enough time and money, I have the ability to figure this out. And if you have that kind of mindset, and I guess it takes a little arrogance. I mean, you have to. There's a difference between being cocky and confident. Um, Confident is being pretty sure that you can do it, and that's what I've always been. And I'll say I certainly got a bigger dose of mechanical inclination and intuition and ability to see 3D in my head than most people. Just a God-given thing. It's not something that I practiced or worked for. I can't take any credit, but that helps a lot. But also, what helps a lot is um, being a incessant student. So, like where I worked, I don't. You guys are probably too young to remember what we called bingo cards. And you used to get your in the mail would come a pack of these cards, or they'd be things that you circled in a magazine. So you'd be going through the machine new equipment digest or whatever, and you'd see all these different mechanical elements, seals or couplings or you name it. Well, I filed for every single thing known to man that looked like it had any relevance to building machinery, and basically built the engineering library of where we worked. Having that kind of overall picture of all the neat kind of things that exist is one aspect of it, and then having experience with all the different general mechanical items, clamping methods and uh, just all the things involved in general engineering. Um, all those things give you a background to have uh, uh, the ability to look at these things with an arsenal of previously either known or done things that you've worked with. And then when you work with them, if you have the opportunity to build a ton of things like I did, then you get experience where you say, oh, this thing works awesome all the time, this particular way of doing things or this particular clamping method or whatever. And you build this mental arsenal of ways to accomplish things. And that's one part of it. The other part is not treating um, tools as sacred. If it's something that's manufactured currently, why are we what are you worried about? If you want to turn it into something else, go for it. If you don't do it right the first time, is it the end of the world? I mean, just have at it. It's also part of that thing of if you want a skill, make a project to practice that skill where it's not the customer's product, and build your skills on that. But pick things to do that keep incrementing up your your skills. So scraping, lapping, all metrology, all these things, all are things that take practice. They take some study to get it to the point where you understand it intimately, and that means being able to explain it to somebody else who doesn't have a clue and hit it from 6 different angles until they actually get it and say, oh, okay, I really understand now. And when you can do that, then you know it. And those are part of the things. But the main thing with Henry Holster's question there is just do it. Just pick something that you want to accomplish, have at it. If you have people you can ask for some guidance, get some guidance from them that maybe might save you some missteps, and just do it and keep building on that.
So you're speaking about creating a library too of references. Devin Peck asked, for a short list of books related to machining that you recommend. And I know you recommend The Foundations of Mechanical Accuracy and Holes, Contours, and Surfaces, both from Moore. Are there any other books that you think are, every machinist should have in their library?
Well, some of it is. I keep in mind, I am not a degreed engineer. I'm simply a high school graduate. But if there was something that I needed to have a better understanding of mechanics or whatever, I would go study that particular aspect until I really understood it. And that's another one of those things in the arsenal. So being able to do simple beam calculations, yeah, just don't just glaze over when there's something that you haven't seen before. I'm no whiz on math, but I've just learned to take a programmable calculator that can simplify some of the algebra for you. If you can punch it in the way it looks, you can get answers that are correct. And learn to punch in these formulas and run through them and say, oh, okay, I can see what's going on here. And don't let the initial this is overwhelming stop you from proceeding, because seriously, I'm no math whiz, but I've learned a lot of it on the way when I needed it. And I think that applies to all this. So where I was going with that is I'm probably more engineer, which allows me to be a better machinist, because everything I see, I'm seeing the engineering underneath it, and which is super powerful. So a lot of the books that I relative to machine design things are kind of more advanced, and they're when I say advanced, they're not actual hands-on machining related. They're more about building machines and metrology, how you build instruments and all those things. So that's kind of a different aspect of it. Probably the best thing for me to do is I'll do a post on Instagram where I actually show the cover of the book that shows who they're from and let people see them there. It'd be easier than going through some of that.
Yeah,
But
that
on
sounds
that
great.
top,
We'll link to it.
yeah, on that topic, I think what some people when they discuss um, books, and as soon as they see some math and they see some advanced calculus and things, and they just say, "Okay, this book's not for me." I go through those books. I know basically what some of the simpler calculus is. I can't do it myself manually, but I understand what's going on with calculus, which is it's actually a good thing to understand. There's a big difference between being able to do calculus yourself manually, but understanding what calculus can let you calculate. Just understanding the difference between differential, integral, what they're used for, why you need to know some of those things if you're going to be calculating things dynamically. You don't have to understand how to do it, but understanding what it can do is important. And then you can go through these books. You go to the thing, you read what you can read, you read what you can digest. When it comes to the math, you say, I don't have to calculate these things, but understanding the concept is important. So lots of books that are really deep, you can go through them and gain a lot of understanding without ever touching any of the math. One of those that I'm going to mention here is Introduction to Tribology by Bouchan. And that, if you go through there, that helps you understand surface finish, what causes friction, a lot of things that explain some things going on. And that's a book that if you at first glance it's like, whoa, forget it. But you can go through there, read what makes sense, and sometimes um, you might come back to these books after you've learned some other areas and you're up a notch, and all of a sudden some of the stuff that was just a little bit too hard to grasp, all of a sudden, oh, okay, now I get it. And so don't ever feel defeated or like I can't do this, because I'm no whiz on this stuff, but I have this can do, I'm not going to stop attitude, and I'll just keep pounding on it until I get enough enough understanding to say, okay, that helped me. I can apply that now. So machining wise, which I think was the question. Oddly enough, I don't have any books that I actually referenced there, because I just grew up in this so much that the vast majority of it is just experience. It doesn't mean that I didn't look through tons of books, seeing all of the different equipment that's available that I haven't run or that. But once you have the basis of it, it's just a matter of, different axes arrangements and what the machine's trying to do and that type of thing.
So a question Tig Welder asked is, have you taken any additional knowledge courses since graduating? I know you mentioned that you're just a high school graduate, but have you gone back or done any classes along the way?
No.
None?
No. But like I said, if there's something that I want to learn, I'll go buy some books. I'll slog through, and I'll glean what I need to glean at the moment, and carry on.
Yeah, makes sense.
So you were saying that if there's a skill you want to learn, you choose a project to do it. How do you choose your projects? Do you find them in a reference material? Do you just do some Google searching and find something that represents that idea? Like what's your course that you usually take to find a representative project?
There aren't a whole lot of most of the things now are refining skills, taking them to the next level, more so than learning a new skill. I'll give you an example. Way back when we bought the company bought the Boss 5 Bridgeport mill, they had a tool presetter that you could buy which was made out of about maybe 2.5-inch diameter discs, about 3/8 of an inch thick, stacked up with 5/8 inch spacers. And they were kind of like round gauge blocks, and they stacked all the way up. And then they had a fork that went in with a micrometer head to measure your tool offsets, your tool length offsets. And so I said, don't buy that. I want to make that. So, so I just took that on as a project, made the parts, hardened them, hadn't run a surface grinder. They had one there, but there weren't any actual tool and die guys there. And just went at it. Laps, from what I've seen about lapping, lapped them. I had my gauge blocks. I had my, electronic indicator, actually lapped them parallel, all that. Just went at it and dove in and built that stand and the measuring head and all that. So that's the type of thing where, yes, and you can't, if you're a real businessman, there's times when that just doesn't make sense. Lots of times. And I'm one of those people that says, I don't care. I can afford to take the time to do it. And what I learn from it will be valuable later on. So that's more or less the thing. The tool room spindles that I'm showing now. There's an example. I worked with Professional Instruments air spindles. I actually bought them for the company I worked at when we were doing the diamond rolls. And we did a diamond roll for a company that was for dressing the grinding wheel to grind the groove in a chainsaw blade, the metal chainsaw blade, the groove where the tongue of the chain goes in. Some of them were spot welded out of sheet, but these were going to be ground from solid. So this went on a creep feed grinder where they were stacking, like, I don't know how many blades side by side, spaced apart. And the diamond roll was about, I think, 14 inches wide and had, I think, at least 10 sets of diamond rolls, which was 2 side rolls that dressed the width. And then the bottom roll that put the radius in between those, nested in between them, was the bottom roll that put the radius on the grinding wheel. Well, when you start stacking 30 or 40 pieces on a shaft and clamping them together, all of a sudden you start to realize that, oh, wow, parallelism actually means something. Because if you clamp those things together and pull it, whatever out of parallelism is in there will actually bend the shaft. because as those things clamp up and start to pull, and I covered that somewhat in the spindle rebuild video that I talked about. They'll actually pull, and another place that applies is the old horizontal milling machine arbors
Mm-hmm.
that you have where you put spacers and all those. Well, those spacers need to be really, if you don't want a bunch of cutter run out, unless you're going to have bushings real close, support bushings real close to the saw or the cutter, you have to have super parallel spacers, and the nut squareness of the nut face and all that all has an influence on whether that shaft bows and bends when you tighten everything up. So I had to grind all these parts ultra parallel, and that's what those professional instruments spindles would let you do. They're sub 1 micro inch TIR, and they're very stiff facially. Yeah, so they're awesome, and the neat part is you can grind on them by just giving them a spin and grind on one side and just hold a wet coolant sponge on the other side and just keep the speed down. So you're kind of like using your hand with the sponge on the one side as a brake and keep the speed at a reasonable level while you're grinding. And yeah, they're really neat. Anyhow, they're a pain because they must have air on them all the time. You can't just turn them on and off. You have to maintain super dry air and all this stuff. There's a lot of things that are very particular about handling them. So they're not friendly for general tool room use. So that's why I designed the tool room spindles that you see me put on the last YouTube video. And I've also shown them previously in lots of posts on Instagram. It's just that I've never gotten around to working on them again. So I thought I'd dig them out and get them finished up. So that's a project of that type where I mentioned on the video that I was, shooting for sub 5 millionths TIR, but I'm pretty confident they're literally going to be below 1 micro inch. And I've had a lot of, not a lot, but a few commenters who were being very nice and saying, more or less saying, I don't think you have any idea what's involved in, working to those levels that far down. And that is good warning, but I do have a lot of experience working down at that level.
You're Robin Renzetti. Come on.
Yeah. And you've probably, I don't know how many of my Instagram things you've seen, but pretty frequently I'll show grinding a spindle nose on a spindle that I've built, grinding the nose in while it's running on its own bearings. And very common to have, maybe 3 millionths TIR, and that's just with class 7 bearings that the shaft supported on. So I'm really confident that this is going to be way below 5 millionths TIR. But that's the kind of thing that the other thing that's really fun about that is there's a million variables there. There's all different kinds of things to be considered. And once you have a pretty big arsenal, that is just, that is really, that's the ultimate fun. Is you go through there, you take your first cut through the design, and you say, okay, what could be better, and you tack this, and what's the sore point here, and just keep over and over and over again, iteration after iteration, just keep whacking at it as if you're your own design review team, a one-man design review team, and that is where both on an engineering end and manufacturing end, you build up those experiences that are increasing your skills.
Awesome.
Yeah.
Thank you.
Let's see here. What else do we got? I'm trying to pick one that's somewhat in the same vein, but some of these are all over the place.
Oh, well, Design the Everything asked, what are the biggest mistakes that beginners make when they transition from working in thous to tenths? I think that's a good one.
Realistically, there's no difference. The difference is in your measuring equipment. So, if you really want to work to high precision, just bite the bullet and get a electronic indicator and that's probably one of the reasons that I so appreciate the flexibility of things. Is, remember, I had those indicators when I was 20, way back in my career, and that lets you see how flexible things are. It lets you see thermal influences and things in real time, and that is such an education. And then it also lets you see, um, and I'm not saying this in a derogatory sense, but when people put posts up and they say, "Look, no run out," all that means is you need a better indicator. And I'm not being I'm not I'm not I'm not being derogatory in that sense. But if the measurement matters, if your indicator isn't moving, you need a better one. You need one that's showing you all the subtleties of what's going on. And until you get down to 5 millionths is pretty good, but 1 millionth per division is really, really enlightening. But 5 millionths is still good. It's and where I'm getting at there is, it's not a matter of, sure, you need to know some more finesse things about how you get there, and that, sure, you're not going to machine anything, at least not with the equipment that I have, to 10 millionths flatness or whatever, as is. But that's where you learn about lapping and optical flats, and being able to read an optical flat, to see what's going on, how to influence how things are lapping, shape wise and all that. So it's no different than doing something more precise in the shop. If you went from your tape and you say, well, my tape's not good enough for doing this, I need to get my calipers out. And then if your calipers aren't good enough, you say, okay, now I need to get my gauge blocks and a comparative indicator to measure. And all it is the next step is, okay, I need an even better indicator and gauge blocks. And then I need an even better surface plate, that has a better repeat reading, so that doesn't come into play. So, and then along with that is also your increased ability to remove material in small amounts in a controlled manner. So I think that's the real thing. It's not something where it's a whole different world. It's just better measurements and a little more refined techniques, in my opinion.
Okay. Well, so in that same vein, Swansea Road Bicycles asked if you have temperature control in your shop, and if not, what steps do you take to avoid gross temperature swings? And I think on the Home Shop Machinist podcast, you had talked about scraping or grinding in Tom Lipton's level, and how even just putting, rubbing alcohol on one side, you could see it bow. So
Yeah.
in those terms of working in millionths, or close to that, what techniques do you have to not put heat into parts, or to make sure that you're not swinging the temperature wildly like that?
Well, there's several different aspects about temperature. The parts where, and some of it's interrelated. If you have to do traceable measurements to very high accuracy, that requires very accurate temperature control and stability of temperature, because you unless your master that you're using for your measurement, your gauge block, as an example, if you're making steel parts and you're using steel gauge blocks, it doesn't matter if your temperature is 80 degrees in the shop, as long as it's uniform and has been uniform. It hasn't changed, and it's not fluctuating all over the place, because there you don't have anything. But if you're using carbide gauge blocks and steel parts, now all of a sudden you have a problem, because at 80 degrees, they're not expanding and contracting the same. They're different. Or if you're making aluminum parts, you're not going to have aluminum gauge blocks. So now you're really stuck. Now you have to have some temperature compensation, because even though you can theoretically calculate what the compensations are, that just adds a whole lot more possible errors in the calculations. So that's one thing. So I don't do a whole lot of work where the parts are large enough where and the master and the part are different enough that it causes issues. I do have air conditioning and heating in here. It's not anything crazy. It's just your normal, household style air conditioning and heating. But I do temperature checks on the parts in the master if necessary, to see where things are, make sure they're the same thing. And especially lapping, you have to be very careful, because when you lap, you're always going to be elevating the temperature of the part to some degree. So you have to be very careful to let the if it's real accurate stuff. If I'm making my own ring gauge, I will literally let a part sit and soak from one day to the next to make a check, because it takes a long time for the part to have a uniform temperature throughout. You can't just say, "Oh, I'll just run some coolant over it," and that's good. So that's one aspect of it. But that's why I say, for what I do, and as something else, as long as your temperature is uniform, it doesn't affect things like squareness, flatness, and all those things, other than your surface plate. Surface plates are not, the shape of a surface plate does not change from temperature, which people will misstate. So they'll say, well, your plate's different in summer and winter. That's true, but it's not because of the temperature. It's because of the temperature gradient changing. And that gradient, the difference in temperature gradient from the top of the plate to the bottom of the plate, is what changes the curvature of the plate. So that's one thing, if you're doing real accurate work, you have to be aware of. And to do even a double A plate in large sizes, you have to, the federal spec actually calls out that you should be stating on the plate what the temperature gradient was when this plate was calibrated, so that you know what that was, because that can have a huge effect. There's a calculation for it, and it can change a plate significantly.
So I heard you mention that on the Home Shop Machinist podcast. How does like if I have a plate that's soaking in a room for a week and it's not changing, let's say, I mean, obviously it always changes, but how do you
Right.
get that gradient across the plate? What creates that gradient? Is it just exposure to light and things like that, or
No, it's just natural. The fact that heat rises,
okay,
even if you have a room. Well, typically all these rooms are going to have some type of um, temperature control system. The temperature control system, how it's designed, can actually create a gradient. So, like in Foundations of Mechanical Accuracy, you'll see where the lengths that they go to, and reverse flow, and all these things, and a room and within a room, all these things to minimize that temperature gradient. Now, to answer your question about why does that change a plate, I think we're all familiar with the bimetallic strip effect, if you want to call it that. Is if one side, if you have a part that's straight and you warm up one side, it's going to grow, and that means it has to change in length. It has to grow in length. If it grows in length, beam theory says it's going to curve the beam, and that's what happens on the granite plate. If the bottom of the plate is 0.2 of a degree colder than the top, and you lap it flat, and now if you go to 0.3 of a degree, when you do the calculations for the granite, its modulus elasticity, the whole works, it changes its curvature. It's no different than anything else. You warm one side more than another, it's going to change its curvature. So that's what the temperature gradient does. It doesn't matter how homogeneous the temperature is, there's still going to be a temperature gradient top to bottom in it. And that's what causes the curvature change.
that makes sense. How much are we usually talking about in curvature? I mean, I guess it depends on the size of the plate,
Enough that if you're talking a double A plate, it can easily go out of spec from summer to winter.
but oh wow, okay.
Yeah. And that's why you'll hear guys that are good in there. You'll say, okay, it's summertime, so I'm going to actually go a little bit towards the concave side of the tolerance, because I know in the winter it's going to go up. So they try to do their best that the plate's going to stay in spec at both extremes by hedging the tolerance which way it is, whether they actually work in the concave side of the tolerance or the convex side of the tolerance. Because it could be either, you could have the plates within 2/10, but is it 2/10 concave in general or 2/10 convex in general? And if they do that properly relative to summer and winter, what they're doing, which is, and it's not, remember, they say summer and winter, but what they really mean is temperature gradient. And they might not even know that, but that's what's causing it. And then if they do that properly, you get a plate where it stays in spec either way.
That's really interesting.
Wow.
I'll have to talk to the guys that come out and calibrate the plates at work and see what their opinions are and talk to them about that, because that'd be great to pick their brains.
There's a really excellent PDF by Ron, RAHN, Surface Plates, that covers all these different aspects. Gives you the calculations for all this, talks about all the different modulus elasticities of surface plates, and that's one of the reasons I'm such a fan of the Starrett Master Pink, which is no longer available, is that that's a particular pink granite that still has a fairly high modulus elasticity compared to most. And it's high enough that the plate that I relapped, that plate, Master Pink plates were rated at 100 pounds per square foot versus the typical 50 pounds per square foot. So all the plates that you buy off the shelf is typically a 50 pound per square foot plate. And what that means is you can take the square feet of the plate times 50 pounds, you put a weight in the center of the plate, and the plate must not deflect more than half of the tolerance of the plate, the flatness tolerance of the plate from that weight. So a 100-pound plate means that you can do the same thing, except you put 100 pounds per square foot on it. So it's twice as stiff as in behavior. The material is obviously the same stiffness, but the plate's thicker or is a higher modulus granite. And typically most black granites are much stiffer than pink. That's why most of the black granite plates that you look at are way thinner than a pink plate. But that's also why my 3 foot by 4 foot plate is 8 inches thick and Master Pink, and that's what gives it that 100 pound per foot rating.
I was about to say, is that why you see in like mold maker shops these giant tables of granite that are, a foot thick or more?
Yes. Well, the thickness of the plate is actually calculated based on the grade that it's going to be. So a B grade plate can actually be thinner because to satisfy that 50 pound per square foot rating, it can deflect twice as much. And it's also why when people say, "Oh, it was a B plate, but I'm having it lapped to, A," there's absolutely nothing wrong with that. But they have to remember that plate doesn't actually satisfy the AA rating, because it, under the full 50 pound loads, it's going to deflect more than that. But who cares? You rarely ever put that much load on a plate. So it's not like it's a stupid thing to do, but in theory, it's not legally a plate because it's not stiff enough to be that plate.
It's an illegal operation.
Yeah. That's funny.
Oh, man.
So another question, kind of going back to the skills, skill learning and whatnot. Obsidian Tools asks, is there a skill in manufacturing that you want to learn or get better at in the future? I know we were talking about, find a project that could be one of those skills and kind of go that direction. But is there anything that obviously the spindles and whatnot, but is there anything that's really standing out to you lately?
Probably the one thing that I would like to master to another level, and that's kind of where the Mitsui grinder and things are coming into play, is being able to grind mirror finishes on the surface grinder.
Okay.
Not just for the novelty aspect of it, but for the practicality of it. If you're doing gauging and things, where you could grind those finishes, and obviously those finishes along with geometry that's in the same realm. So that's probably one of the things that I would like to get better at. I'm pretty much self-trained relative to grinding, and that's why people think I'm you know joking when I say I'm not an expert. I truly do not consider myself an expert in anything. Um, the spindle rebuild bit. When I said sure, just because I've done a gazillion spindles does not mean I'm an expert. Uh, I don't know if you guys saw the Kern spindle laying out on the table in an Instagram post with
Uh-huh.
like 50 different lines coming out of it. It's not like I can't understand what's going on in that spindle, but I've designed a lot of spindles, and I know there's lots of things I designed in my spindles that if you don't know some of the nuances that of how I've designed this thing to go together, you're not going to put it together properly, and it's not going to work right. And those spindles are full of those things, and just tons of stuff. So saying you're an expert to me is silly. That's why my hashtag is practitioner of the mechanical arts. I'm always practicing, and I'm serious about that. So same way with grinding, pretty much self-taught, but I think I have a pretty good handle on grinding, especially on dressing parameters, how it affects the way that wheels grind, things like that. But I'm not an expert. But that's something I'd like to get an even better understanding of.
Okay, so I guess in that uh, line of questioning, do you have any projects lined up to push your limits on that?
Well, originally I got the Mitsui thinking I was going to do a quick rebuild on that and start doing precision ground stones and have a bigger, nicer grinder. And then I realized, you know what? I really want this thing to be a ultra tool room machine, and I've developed enough skills with machine building, scraping, lapping, and all that to be able to do that. But that takes time, and so I said, okay, that's why you saw me switch gears, and I'm automating the Harrod grinder, and that's so that I can turn it loose, automated to grind precision ground stones and other things, and still be a full hands on, very handy grinder. So it will have hand wheels for everything. You could run it just like a regular grinder, even though it's all motor driven. So that's where I am, and I'm that thing's going to be running very shortly. So then I will go back to the Mitsui and take my time on that, and that will probably be a full CNC grinder, um, and be just go crazy on the geometry and all aspects of it. If you've seen any of the videos on the needle cages and things I made for it, the ball cages and stuff, I'm out for blood on trying to hit every possible aspect of making it better.
Awesome. Well, that's going to be an awesome or a great project to follow along with. It seems like it's going to be quite the machine when you're done.
Yeah, that's a really nice grinder. I especially love the super high columns on those machines. A huge amount of space under the wheel, and if you've followed any of my videos, you know that to me a surface grinder is just the a playground to do the extreme one. So the more space, the merrier.
Speaking of equipment, a couple people asked, and Tom Machinist is one of them, what is the reasoning for you getting the Tormach lathe? And I guess
I
talk
only
about
have
kind of that backstory there.
okay. I only have 500 feet of square footage that all of my machinery's in. When you see pictures of the surface plate and the weld table, they're out in the garage, but the actual machining space is in 500 square feet. And Tom Lipton will attest to the fact that this is like a black hole. The amount of machinery that's crammed in here. So space is a huge item, and I'm not really interested in mass production of anything. And I had a job that I did manually. I make some production hydraulic expander that are used in uh, automotive grinding, and they come up every so often. And it was enough of a thing where I could just pay for the machine on one run of these. And I like the design of the Tormach. I know full well that it's a hobby level machine, but I also know full well that if whatever I don't want to be hobby level anymore, I'm more than capable of altering. The space was awesome. The not needing three phase was awesome, even though I do have phase converter. And I like the huge amount of travel on the. It's got 12 inches of X travel, and the gang plate style on there just gives you lots of flexibility, and also the ability to swing large stuff. Um, so I just liked all those aspects of it, and the price was good. And while I'm on this topic, that's why I got the Tormach. Uh, when I got it, I actually looked for things that would be shaky, and there were quite a few. But Tormach was very happy to hear my constructive input. And there were things like the concentricity of the timing pulleys on the shafts, and things like that I redid right off the bat before I even ran the machine, because I was checking belt tension, and I would spin the belt, 180, or spin the pulley 180, and the belt went from tight to loose. So I said, okay, yeah, major concentricity issues. So you can't hold tolerances when that's the case. So it wasn't that the machine was total junk at all, but I finessed all those things. And the machine is impressive. I mean, it holds size extremely well. Another thing happened because of my inputs and them. I gave them lots of other things that I won't cover, but they're things that they weren't aware of that I sent them things on relative to machine alignments and stuff. So I was basically a friendly person giving feedback and not flaming them and not going and complaining about it on the internet. So they said, "Hey, would you mind running clear path servos on your lathe if we send them to you? And it's going to require you to do all the mounting and all that stuff." I said, "Sure." So they sent me an entire a new control panel with the drives, and I did all of the mounting of the clear path servos. So that's why my machine is immensely faster than a regular Tormach. I'm one of the 2 beta test sites for the ClearPath version of the machine. Mine, I put the stuff on afterwards. The other, Cliff, um, he has a YouTube channel in, I think, Australia. I'm trying to think of his name, or think of his channel's name. Thread Express is his YouTube channel. His was sent to him, done by the factory. But yeah, it has like 260 inches a minute rapids, and yeah, it really does well. So yeah, with tweaking a few things that are important, the machine's crazy good. It has the normal, warm up, chase a few tenths here and there, but once it's up and running, literally just adjusting for minor tool wear, it's spectacular.
Wow, that's fantastic. So in that same line, Stefan asked, "What's what machines you own, and what was the decision making process behind each one of them?"
Um, Obviously, the Bridgeport is the one I originally bought as a kid, and that's not going anywhere. And I mean, Bridgeport was always the machine to have, way back then. Honestly, there are better, in my opinion, there are better Bridgeport versions than the Bridgeport that are better quality that are made. Meaning, induction hardened table ways and machine ways and just lots of stuff. I'm not mentioning any brands or anything, but a lot of them are way better than the Bridgeport. Not that there's anything wrong with the Bridgeport, but there are ones that are actually have a lot of features that are even better. So I have the Bridgeport, the roll-in saw. I bought that new, and I've had that forever. Can't recommend that highly enough. You guys are probably sick of seeing it on Instagram. The Harrod grinder. The Harrod grinder I got from where I used to work. That used to be there's a company called TrueTech that took over. I think actually took over Harrig as relative to replacement parts and stuff. And some of the centerless grinding machines that they make, it's basically a centerless attachment on a Harrod grinder. And originally was Dead True Company made that. The company I worked for bought one of those for doing jig grinding mandrels, grinding them, and it got worn out, got not used for that anymore. And they said, "Hey, you want to buy this grinder?" Yeah, so I said yes, and cleaned it up, and that's been my grinder. The track mill was my nephew bought one, and I was pretty impressed. And I went to the tool show in Philadelphia and looked at one there and talked to the president of the company, asked him, construction wise and everything. And I was pretty impressed with what I saw. So I actually bought the tool show version. And yeah, that was excellent. I still love the machine. Just love the capacity, especially the real high Z travel. It just works. Yeah, it's not going to do high speed engraving. It can't digest a gazillion lines of code from Fusion. Matter of fact, it can't even run G code. So there's lots of negatives about it, but for what I do, it's good. And there's times when I wish I had a more capable or more modern machine. It's not because I'm scared of G code. I've done tons of G code programming. Keep in mind all those fancy shapes we did on those diamond rolls. We did that with calculators. I literally wrote a program on my HP 41C where you could plug in your straight line segments and then just tell it what the XY coordinates were of these in sequence and tell it what radius you want fit in, and it would spit out all of the tangency points and the arc centers for programming. So I literally had like 6 people doing manual programming using 41Cs where we did all the trig for the line work for where the points would be, and then that would do all the hard work of fitting the things in. So we did crazy stuff with manual programming before we even had CAD. So yeah, I'm not afraid of G code whatsoever. It's just a matter of, and I use Fusion on the Tormach. So yeah, I'm not afraid of the technology. It's just the work I've done so far has not required it, and the track is pretty good at doing things pretty quick and dirty. And the Harding, friend of mine that I worked with, he had a friend that worked at a scrap place, and somebody scrapped that Harding, and he got it for a ridiculous amount of money. I think it might have been $3,000 or $4,000, and he completely pimped it out with all new plates and everything, paint, the whole works, and he sold it to me for a little bit more money. And so that's where the Harding came from, and that thing is, well, on that topic, I still don't think people get what a high-end digital readout with a solid tool post and a tool library of a gazillion tools all set up, what that does on a machine like a Harding. And Stefan will tell you basically his machines is a same version of that with his MCO. It's just such a joy to run. The stuff you can do on there. I mean, you can hard turn to to tenths, and it's just amazing. So I don't think people understand how neat that is to have a machine where I literally can go up there, grab a tool off the tool thing, punch in the number, and absolutely will be less than 5/10 off the size without even trying. And that's just amazingly powerful.
I have to ask
So those,
because of Tom, but what's the biggest cut you've taken on your lathe?
oh yeah, I heard all that stuff. Yeah. So okay, so I have a challenge. Let's
I knew it.
let's see who can take a half inch on a side cut on a high speed steel blank. Let's say 1.25 inch high speed steel blank on one side, and I guarantee you the Harding is going to purr through that, and a lot of machines won't. There, there's yes, a Harding is underpowered in many ways, but a mistake that a lot of people make is thinking that low range is more power, and it's not, because it's actually a lower speed on the motor that's half the horsepower. So yeah, you can run out of horsepower quick on a Harding, but on work that's 2 inches or below, forget it. It's just as competitive as anything else. I can bark off a 1/4 inch on a side on 4140 on the Harding all day long. Not at 6 inches, but at 2 inches I can, and most of my work's in that realm or below. But one thing about a Harding is that it's an extremely rigid machine, and that's because the headstock is solid. There's no webbing in there. That's a hole for the bearings and the spacer tube. Other than that, it is solid iron all the way down to the bed. The bed itself is very, very chunky. It's very, very massive. The ribbing and everything's massive. So if you look at a Monarch Triple E and look at the structure of it, it's not as rigid a machine as a Harding is in that area. So even though it's big and all that, and that's a wonderful machine too, and basically has a lot more versatility in size and everything else. So I'm not throwing any stones at a Monarch, but it's tough to beat the rigidity of the HLVH. It's just a very solid, the engagement of the saddle is a huge amount of contact area on that dovetail bed. So it's just a beast when it comes to rigidity, and that's why I can hard turn on it so well, and part and all that stuff is yeah, it's just a beauty.
I just had to do that for Tom and for all the
yeah.
Let's see.
Oh, well, this is a quick question. Hexapoded asked, will you ever finish the helicopter, or did you finish the helicopter and fly it?
No, I will never finish it. Not because there's anything wrong with that. That accomplished what I was after. I did just recently clean up all the parts, and I'm going to do a YouTube video on that, showing the parts and talking a little bit about the how some of the parts were machined and stuff. But yeah, that was an awesome learning experience. It was just fun designing the parts, and it was fun making them. Did a lot of wacky setups, and remember that was before digital readout was on the machine. That's all just plain old Bridgeport dials, and yeah, just a lot of fun. So no, I will never finish that. No, I have flown helicopters since then and enjoyed that, but I'm just a machine nut. That's where I enjoy the most.
Yeah, it sounds like it is finished. It's just not a helicopter. But it finished your purpose, so that's what matters.
Yep.
Kind of a question going back to talking about learning experiences and whatnot. Hermit Shed asks, would you ever consider writing a book? I think that's the answer.
I would almost need.
You rather run a machine than write the book.
Yeah, this might sound funny, but I'm sort of a scatterbrain in a lot of ways, even the way that I think. it would be hard for me to stay focused on that and not get caught up in worrying about minor details and it never getting accomplished. Um, and then I'm not sure. I would almost think that well, actually, I'm not sure that Instagram and YouTube aren't a better medium to do those things. Other than a book is really nice for being able to flip to. Oh, where did I see that? And it's easy to flip to it. Where YouTube and Instagram is not friendly for that whatsoever. So in that regard, that could be good. But yeah, that I'm not against it. But uh, to be honest with you, I never ever believed that there would be that much interest in the stuff I do at all. Seriously, I'm just flabbergasted at the interest that people have and one thing I will say is, thank you to everybody, Instagram and YouTube. I mean, I have the nicest people. I have like zero trolls, and just if I ever have a bad day, I just go over and read a few lines of comments and feel like I'm the greatest guy on earth. So really, really appreciate the very kind words and encouraging words, and it's nice to know also that people are inspired. So I think with the time I have, that continuing to do that might be the best use of my abilities.
Yeah, definitely. Well, I think a lot of that goes back to what you said earlier about cockiness versus confidence, and that you are confident in what you know and don't know, but in no way do your videos come across cocky or anything. And so, you know, people react to that for sure in a positive light. I think that a lot of the trolls that, machinists get on YouTube, what have you, is because they come off as cocky or something like that.
Yeah, yeah, I appreciate that, and uh, yeah, and I don't say I'm not an expert in these things to ward that off. It's I really believe that. Do I know more than the average guy? Sure, but that still doesn't make me an expert.
Totally fair.
So, Adam the Machinist asked, any tips for maintaining sanity and happiness when being alone in the garage?
Um,
Read the YouTube comments.
I I well, number one, 99% of what I do, I enjoy doing. I mean, there are jobs that are a repeat where it's not like it's drudgery, but I'd rather be doing something a little more uh, uh, of a challenge. I listen to podcasts. I wear the 3M. What are they called? I can't look at it because it's work tones or something. The Bluetooth headphones that are ear protection, and so I can wear them all day and listen to uh, podcasts. I also listen to the YouTube channels that I like a lot. I will listen to them even though I'm not watching them, um, just to give the people the full advertising benefits. I'll let all the advertisements run, and I'll comment on them just as a means of support. And if there's something, usually I can almost picture what they're doing, enough that I don't. And if I can't, I'll run over and take a look and say, what was that? And oh, okay. And so it's a way of supporting, and it doesn't cost anything, and I still learn things here and there. So here's that. What's he talking about? And go over and look at. Oh, that's cool. And yeah, so that's what I do typically. Um, when my son is in the shop, which is full time in the summers and a couple days a week in between when he's in seminary. Um, we will listen to old time radio shows, which are excellent. They're really good. Jack Benny and just a lot of the old The Shadow and just all different kinds of them. They're really good. Just plain old good, wholesome, you know, fun, and they're just and radio has its own kind of feel anyhow. So we'll listen to those, and we'll listen to music. He's the music person, so when he's in the shop, I get a lot more variety. He's totally in control of what we're listening to, and yeah, we go from there. So, and I'm in heaven when I'm in here. So there's nothing. It's not hard for me at all.
Awesome. So Auntie Ains asked, a few years back, you made videos covering both electrical engineering and machining at the same time, with the usual attention to detail and precision, but nothing on electronics since. Is there any reason why, or do you plan on bringing any of that back?
My electronics, I've always been a wannabe electronics guy. Um, when I talked about that um, turnover folding machine, when we made that, we used a mechanical adjustable timing unit called a Candy. It was made by Candy Company. That was a cam unit where you could stack however many adjustable on-off things you wanted, and it was per 360 degrees of rotation. And there were two knobs on there where you turn the on time and off time in degrees. So you could take something like where you had a master shaft running and you needed to time all these, pick the valves for picking up the thing, the valves for making it oscillate, all the different things that happened. You could time those mechanically using these switches by just stacking them up, hooking them up, and you could do. These were dynamic. They used like an actual differential in there. Whereas you turn these while the thing's running, you could do these things live in real time. Wherever you set it, it would stop. The problem was that even though the machine would run, it just they weren't quite accurate enough for what we were doing. So I had read up a little bit on digital electronics and everything. So I said, you know what? I can take an encoder, put it on the shaft, and take this into a counter system, and then use a comparator to compare the position to BCD thumb wheel switches set to the degrees and things that we needed, and do this electronically. So I actually built one of those and put it in there, and they ran on that for a long time on a homebrew. This is before they existed that you could buy. That they now they exist. That it's something you can buy right off the shop or right off the shelf. So always had an interest in electronics in that realm. Um, the EEV blog was just an avenue for me to um, do something interesting and exciting, and I enjoyed that. Um, I'm still not. I'm when I say wannabe, I'm serious. Even though some of the stuff I did was very technical, it was technical on a very very small thing like high precision, low ohms measurements and things like that, where it's not all that complicated. It's not like understanding um, uh, something like a FPG or something like that. The real crazy stuff. So that's where that came in. Now, obviously, if you half the things you see, most of the things there were machining related, and if you like machining aspects, the things I did on the Ultimate Kelvin connection, part 1 and 2, and uh, things there's some really crazy machining going on in some of those. I've mentioned to people before, don't let the electronics aspect of it push you away. If you can stand a little bit of electronics aspect, 90% of those is machining. But some pretty neat things going on there. But yeah, that was just an avenue. And then what got me off of that onto the other was when I said, you know what, I'm isolated and I need to, see what's out there. And then that's where I uh, watched some videos, saw Tom Lipton, kind of liked his stuff, and then one of his videos mentioned about owing the giving back to the trade that has been so good to him. And I was like, you know what, that applies to me. And that's when I started doing the machining videos, which is really where I belong.
That's great. Are you right-handed or left-handed? Fabricator wanted to know.
Right-handed.
Do you enjoy cooking?
Yes.
Are you a Freemason?
I'm not a Freemason. On the cooking, you guys would love. You, I'm just as obsessive with certain things. So like one of our Friday night, one of our Friday night routine is we stop at Aldi and get one of their take home pizzas, which are really good, and bring the pizza home and take all of the meat off, rearrange all the cheese more accurately, dice the pepperoni into quarters, lay it out very carefully, redice all of the sausage into much smaller pieces, and respread it on the pizza, and then put some crushed pepper seeds on the whole thing, and then into the oven for a little bit to cook the crust, and then turn the broiler on and nuke the top so that the meat gets cooked. And so yeah, you get a kick out of seeing that.
What indicator do you use for that work?
But what's really funny is my son initially had no interest in the mechanical whatsoever. Really was thoughts of working here. He'd rather work at the local Dairy Queen equivalent than work here. And but then he realized he could make more money here and worked here for several years, working well, but just no interest. Not where he was not being useful, but and then all of a sudden he kind of like something clicked and he took a little more serious interest in it. And now the whole seeing everything as from a mechanical engineering perspective, because every time I have a moment to teach him something at a deeper level, I do. And we'll stop and we'll discuss it and I'll, give him background information, all that. And if it doesn't click, I'll explain it 15 different ways until, oh, okay, I see what you're talking about. And now he jokes because now even cooking, cutting things with a knife, everything, he's seeing things and techniques and all that. And he's like, I'm forever ruined, Dad. So it really, really nice to see that carry on.
So along those lines, Laney Machine Tech asks, do you have any mantras, aphorisms, or personal philosophies that you keep in mind? And so I know one of those that you mentioned is everything is rubber. If you want to elaborate on that, or if there's any others that you kind of keep in mind while you're approaching work.
I mean, obviously, I didn't invent everything is rubber. That was around way before me. But it's very important for a machinist who's serious to understand that and to realize that everything flexes, no matter how stiff you think it is, and to understand it enough to realize how it's influencing what you're doing. I would say the most valuable thing, which is kind of what has um, been what has allowed me to be successful pretty much everywhere I go, is um, never never stop on the first thought that you have on doing something. You got to get to the point where, especially like job shop work or any of it, but especially job shop work where you're kind of under the gun to perform and get it done quickly. You need to be able to mentally hit it 15 ways in your head quickly. Think it through. If I do this way, blah, 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 all the way to the end, and oh, okay, there's a problem here. Oh, back up. And if I do it this way, we'll get rid of that problem. Or oh, all right, that works good, but there's this one little thing, and basically, in your head, go through and attack this, both in machining and engineering. There's things I spend, well, I have the luxury of things that aren't production, like the toolroom spindles and things, of sitting down, doing sketches, thinking of this, and I'll come back and then I'll, write the thing. Okay, all pros and cons. What's good about this? What's bad about it? and just over and over and over again, keep doing that. And after a while, you get this attention to detail thing where you're nitpicking every little mechanical aspect of what you're doing. And once your mind gets in that pattern on everything you do, it's what lets you refine a design quickly. It's what lets you make up the first part without scrapping it. Um, because obviously you need experience, other experience to go along with this. You can't just say, oh, I'm going to do this and start out with no experience machining or engineering. But after a while, you get to a point where you just don't settle for the first idea, and get to the point where you have enough of on your mental engineering arsenal to be able to attack it multiple directions until you get there. There's times when I'm designing things and I've just got this like gut thing. I've got something that's totally workable, and there's something about the design I just don't like. It's just something about the way the parts look, the way they're interacting or whatever. And I won't settle until I get to the point, change this, change that, change material, whatever. And all of a sudden you get to that point like, oh, there it is. That's it. And that would be what I would say work on that ability to mentally go through these gyrations in your head, and so that when you do something, you've already beaten it up. And you may need help. You may need people to help you do that. Say, hey, help me. Here's what I'm thinking. And obviously, in the beginning, you need some input to help you do that. But work on getting that where you're not just getting a way to do it isn't the end. Back up and say, okay, is there a better way to do it? Is there a cheaper way to do it? Is there, on and on. And as you guys well know, when you have to get a part out the door, sometimes, well, usually you have enough experience that you've done things similar. You're not doing something stupid. You know that this is going to work. But when you get in something new, sometimes it pays to really think it through and say, okay, what problems could I run into and all that, and do it mentally beforehand.
Totally. Yeah, I think we've both been bit by plenty of not thinking through things
Of
before.
course.
So you learn real quick.
It is a chicken and egg thing. It's easy to say when you've got a lot of experience to do that, and you got to start somewhere. But if you're keeping in mind that that's the goal, is to keep building up your thing. And when I use the word mental FEA frequently, and I'm serious about that in saying, there's a book I will put on the book list. It's a book on beginners pitfalls that beginners would have using FEA. And since Fusion has FEA for free, it would really pay people to do some finite element analysis, even just rudimentary stuff, just to get a kind of a feel. Because seeing those things in motion, seeing what they do with under load, and just getting a little bit of feel, after a while you get to where you look at something and you can look at that part and visually say, okay, here's the cutter loading, here's the direction. If I'm rotating in this direction, which way is the part going to deflect? And that's a huge skill for a machinist, especially things like slitting saws or anything where you've got like a flexible mount or a blade that's got a real, a slitting saw, like a large diameter slitting saw and slitting. Most there is no need to crash with slitting saws. Meaning, if you understand and look at all of the things involved, look at it as a system and say, okay, if I go this direction, even with ball screws and everything else, taking anti-back, being able to climb or conventional and all that without problem, there are definitely ways when you look at that to say, what is the cutter force doing to the part? The shape of the part, is it, the bottom line is the flex caused by the cutter forces and directions going to increase my depth of cut? If it is, that's a crash. which all that means is you have to either change directions or how you approach the part or support the part or whatever, such that when you cut, the forces that go in the part are making the part and the whole cutter system, the arbor that the thing's on, decrease the depth of cut. Then you know you're not going to have a crash. And I've covered some of that in my grinder things, looking at grinder setups and thinking about how whether or not they're flexible to if they let loose, are they going to increase the depth of cut? And that's basically where you rocket something off the chuck fast enough to put a hole in the back guard, or you don't. And so, and that's one of those skills that is you know, people don't take the time to think. Well, they don't have the I shouldn't say they don't have the background or the practice of analyzing that. And that's a real very, very useful skill, even if you're doing all your programming with Fusion or whatever. That doesn't cure the problem. You still have to understand what the cutter forces and the deflections of the spindle, the cutter arbor, and the part, what they're going to do to the situation.
Definitely, yeah. I think there's a big push from some people to skip manual machining and skip, hand G coding things, and I think it's only a detriment to those people in the long run for that reason.
I really should do it. I've considered doing a video where I actually use like a rigid foam arbor and parts and everything, where I, without turning the machine on, I just manually turn the spindle and show the deflections of the part and cutter system in different approaches, where you can visibly see the part and the cutter, this thing where I'm talking about, as you feed in, as parts deflect, the depth of cut increases, and that's basically a crash, because once that starts, it just whoop, and it's over in a second, and you never even have a glimpse of what happened. So seeing those deflections without crashing a machine and showing, okay, here's how you can do that. It might be just turning the slitting saw over and running it in the opposite direction, in order to get rid of that. And just various things like that. But that I've considered doing a video on that before, and I probably should.
Yeah, that
Yeah,
might save some people.
For sure.
Speaking of crashes, what is the craziest thing that's happened to you in your career
Oh, let's see.
that you're willing to admit or that you witnessed?
I haven't. Oh, I have a good one. I have a good one. This is awesome. I'm glad this came to mind. And this is ugly.
Oh boy.
So one of the things that we were building back in my working with my engineer from Pepperidge Farm, we were building a machine to mechanically sandwich Milano cookies from Pepperidge Farm. So you have the cookies that are dry, and then you have the cookies that have gone through the enrober and gotten chocolate on the bottom, and then they go over a roller where they get flipped. And then they had lines of women taking the dry cookies from an upper conveyor belt and grabbing them, one in each hand, and putting them on the lower ones at the bottom, just as fast as the belt was going by. So we were building a machine to mechanize that. And so I built this thing that had all these, crazy rotary actuators and stuff to raise these platens up and down with suction cups and all this. So I had this piece about, must have been 36 inches long, maybe like an inch and a half by 3 aluminum bar. And I made a homemade gun drill to drill the full length, this full 36 inches on horizontal boring mill. And the hole is about, I'd say half an inch off of one edge. And all this was air. So it didn't have to be super precise. So I had it bolted directly to the table of the boring mill, and close to the face. The end of it was close to the face, so I could get to it with the chuck. And Mr. Pyle, the place I worked was called McGuckin and Pyle. Mr. Pyle came over. He says, "You really ought to have that, up off the table." I said, "That'll be okay." So I drill the hole. Right, it's working great. Go through, clean through the other side, and it's probably within a 16th of an inch of being on the same location on the other side. I'm like, oh, smoking, right? And then so back it out, and I take it off the table, and the drill went down out of the part into the iron table, and of course the iron was much easier, much harder to cut than the aluminum. So it went down through and did about a maybe 40 thousandths deep groove where it went down, and then it went back up into the aluminum and out the other end. So there's this stripe on the table about a foot long that goes from nothing to about maybe an eighth of an inch wide in the table. So yeah, that was a good one.
Oh my god.
Oh, wow.
Yeah, you ready for another one? Since we're on embarrassing moments here, same place, and it's a pretty big shop. I don't know how many square feet, but 3 real big bays, and we're working on this. I'm using a bunch of pneumatic stuff, and so the air pressure was lacking on where I was working. So I go over to the main regulator for the whole building coming out of the main compressor and jack it up, right? And I go back in there and it's still not doing anything. And so I come back and I jack it up again, right?
Oh my
and
god.
all of a sudden I'm back working there. All of us there that hear this explosion. And it blew what happened was the compressor was not keeping up with the demand because there was a lot of use everywhere else. So I wasn't realizing that when the compressor came back up, I was looking at it thinking everything was hunky dory. Well, when the compressor actually caught up, it went way past what the bowl was rated for. So it blew the bowl right off of the the whatever was after the regulator. So I got a scolding on that. Like, yeah, in hindsight, yeah, that was pretty stupid. So, yeah.
I think everybody's blown up something in an airline system at one point or another. That's a rite of passage.
And just for some of my my Instagram followers, that proves I'm not an alien.
Yeah.
A good question from Colin Smith was, is it mistakes that ruin parts or projects, or only minor things / inconsistencies that make you learn the most and gain the most experience?
That's a tough one. I think most of the now mistakes are like not thinking things through or making a dyslexia type measurement. Because after a while, I've been machining 57 years. It's not that you don't make mistakes, but after a while, if you're not learning enough to not make them very often, something's wrong. But obviously I still make mistakes. But I would say most of them, end up being the like I said, dyslexia type thing, or being in a rush, or being distracted, or something like that. It's not that the approach was bad. The process was bad. It was the executing was bad.
That makes sense. Luke and Jay asked, "What's the coolest project you've been involved in?" So we heard your mistakes. What about the successes? What's the coolest one, or coolest for you, that you've been involved in?
I saw that one, and I thought about that a little bit, and I'm not sure this is necessarily the best answer, but it probably was my entire job working for Mr. Dunnington, in that was basically a big project of, hey, we're going to make diamond rolls and we've never done it before. And there's a lot of stuff to figure out and do and tweak and all that. And basically that was 17 years of that, and making the spindles and all that. So I would say that whole arena was the coolest thing I was involved in.
Okay. I mean, it sounds like a pretty epic learning experience and project, and everything rolled into one.
Yeah. And that's why I say that I look back at my life and think, wow, man, you were just the right person at the right time at the right place multiple times. And I just look at that and say, hey, that was God's hand on directing my path, in that. And I give him all the credit there, because uh it's just once in a it's a once in a lifetime thing. Only one person gets to do that. And obviously there were other people involved at Dunnington that had huge inputs in this. I don't want this to come across like I was I was certainly the main mechanical driving force there, but there was a huge amount of very talented people uh working with me on all this stuff. So yeah, I don't want this to come across like I was the only only person there.
Well, it sounds like
Okay.
you enjoy every bit of this, so especially in the past experiences. So I'm glad it's working out for you in that direction.
Yeah, it's yeah, definitely fun. And yeah, just you know all of the opportunities are there. Just the to be able to build multiple machines, and convert machines for other purposes. And uh you probably heard my scraping story about buying the surface plates after reading Foundations of Mechanical Accuracy. But then there's an example of, I want to know how to do this. I'm going to get good at it. And then as soon as I'm good at it, we start building all this equipment that requires lots of scraping. So it was like, well, that was handy. And and on and on. So yeah, just all of these opportunities to have a place to practically have a need for developing a skill.
So, in that same line of questioning, Stern made ask what projects or jobs were the hardest that you've worked on?
Okay. The I did a job where, for turbine blades, there's the kind of the fir tree section where you have the what looks like a Christmas tree, where it slides into the main hub of a turbine. And those are usually ground. And then on the other end of the turbine, you'll have the seal section, where it's got different shapes and things for the sealing area, where it's got ribs and stuff to form the seal area. And the vast majority of what we did was, it's even like spindles. They would come with the spindle that they have, and they say, we don't like this because it breaks down too often, or this or that, it's not stiff enough, or whatever. And we would just dive in, and I would design something better, and I would address all of their concerns. And we'd build it, and that was that. And also did that with some fixturing. And the fixturing was for a fir tree, and there's a method of doing that where you very precisely hold the turbine blade on defined gauge points on the turbine blade that are where the entire drawing is staged. And if you've ever seen a drawings for a turbine blade, if you ever want to pucker about something, you get a drawings for a turbine blade that might be 10 size sheets of drawings with yeah, I mean, just insane. And all of the different angles, and how they're supported, and all of the angle, different angles and things of where all these things are relative to the, the kinematic mounting that they've done with the gauge points. So you take all that and you make a fixture that holds the blade on those gauge points, and then fills in around the blade a block with all of these special grooves and everything, so that the block can be physically split off after you've held it. So you're basically putting this precision block that's molded around the blade while the blade's being held precisely in location. So it has to be multiple actions. So you have like these sides to pull out, ends to pull out, and everything to get the shape of this thing, because it has to have all these special notches and things such that you can break the blade off without putting any stress on the blades. So this is designing that, which does the encapsulation. So you have to have this all sealed and cooled, and you're pouring molten low melting alloy in it to surround this. And then you have another unit where you have LVDT gauges and these probes hitting in exactly the same thing, but now it's sitting on the block to check to make sure that the part actually is held in the part properly. And then you have to design another thing where you have a press fixture that has all these fingers that go in to snap the low melt apart off the blade without hurting the blade. So I designed this entire thing from scratch, the whole workings of it, the whole thing, and build it at home, as a contractor. And that was one that really had me like pooping my pants on whether this thing was going to work or not. and it did, but it really had me like where my confidence is a superpower. I was wondering if I had eaten some kryptonite because I was wondering if my superpowers were diminishing, and I was going to have egg on my face. But it worked out. But that really was. You can ask my wife or son. Was there ever a time when Robin was like, "Oh my God, I think I might be, I might be out over my skis a little bit," and that was it. But I survived.
Oh man.
Oh wow. So both Spencer Webb and Josh Hacko asked, "Who was your mentor?" And then Josh had also asked, "What was their most memorable advice, or what was memorable about their advice?"
Well, my mentors are Richard and Wayne Moore from Moore Tool Company. Neither of which have I met, but Richard Moore was Wayne Moore's dad, and Richard Moore is the one who actually, did the original Moore jig borer and jig grinder and all that. Wayne is the one who, put foundations of mechanical accuracy together. That literally, next to the Bible, that's the most life-changing book ever for me. I mean, it really did alter my course. I was just so enthralled with that and the precision and everything that took my interest in precision, just kicked it up a notch, and I was just, inspired. So they're my mentors. I learned a lot of things from a lot of different people, but I really didn't have a mentor. I was so driven that, as an example, in the shop at McGuckin and Pyle, nobody there was interested in the stuff I was interested in. Nobody cared about, precision, high precision stuff. Huge amount of very, very good people, but nobody was into it. And my brothers were helping. My brothers really, they certainly helped me, but it wasn't like they held my hand or anything. I might ask them questions now and then, but um, I think I was just so uh, had such a drive, God-given drive and interest in this, that that was really what motivated me. And most of the places that I worked, I had a higher drive than most of the people there. And like I said, lots of people that worked there learned lots of little things here and there, but I really didn't have an actual mentor, somebody that was like my I went to as a guide in general. And I'm not saying that in a boastful way. It's just the way things were, just like I said, I got an overdose of mechanical inclination and passion for this stuff, and that's kind of what carried me through all this.
Yeah, makes
Yeah, that
sense.
totally makes sense. Yeah.
So this is kind of a different question, but I like it. Tom, the machinist, asked, "Does Robin have a 3D printer?
I do not.
Are you gonna get one?"
Not because not because I wouldn't like to have one. I'm I'm actually pretty frugal, almost to my detriment. Um, so I'm not like a tool hound as far as buying, collecting lots of tools and stuff. Like I don't even have a disc mic. Can you believe that? All this time I've been working at because I buy tools when I actually have a need, and I say, hey, I gotta get one of these because this is I have so many times when I need one of these. It's be stupid not to have one. And there's lots of tools like that that I don't have that lot, and some of that's because I'm not like a true job shop where you get anything known to man coming in the door. I've had a kind of a narrow band of work stuff that I do. Therefore, my tooling and stuff has kind of you know uh, been on in that vein. So there's lots of neat things I could do with a 3D printer, but they're still evolving. There's nothing pressing. Probably the things that I would want to do of any consequence, I'd be better off just sending it out at the moment. But I know that I will end up with one because there's lots of cool stuff you could do. But yeah, not yet. And I have nothing against them, but they're getting better and better. So if I don't have an instant need, why not wait and benefit from the shakeout?
Totally. Yeah, they have gotten incredibly cheap and good in the last couple of years, so it's only going to get better from here. Let's see. Metrological apparatus asked, well, two-part. He said, ask him to talk about something we wouldn't think of. He's really good at that. But then he also wanted to know about your not so secret coaxial indicator design that we never saw anything of. Or is it a homebrew dial bore gauge?
Let's see. Um, probably the only thing that's somewhat related is I really enjoyed airbrushing, and I think I posted that one spindle cross section that I did for the uh, brochure for our company. That's something I really enjoyed, and but yeah, like I said, machining is my real hobby, and if I wasn't married, I'd probably be out here 24 hours a day, other than sleeping. So yeah, I just really, really, really love doing this stuff. Oh,
And then what about
bore
your
gauge. Yeah, the coaxial indicator was a design that I showed Tom Lipton when he was here, and it was basically a taking all of the negative things that are in a typical coaxial indicator and making it such that it was capable of much higher accuracy. Um, so that's something I might make. So I probably won't show that design. Um, I've learned that if I intend on making something, it's not good to give people a how-to on how to build them. uh, not that there weren't plenty of people who knew about grinding precision stones before me. So I didn't invent them. I just think I made the world immensely more aware than they were before about them and how they work and that they really are magical. And so yeah. And then the dial bore gauge, I've shown the one that I did. What it's all flexures and that's from a frustration of the um, relatively poor performance of a lot of bore gauges. Just putting a 10th indicator on a bore gauge or a 50 millionth indicator on a bore gauge when the mechanics the hysteresis of its motion can't sustain that is very frustrating. So when you're trying to do single tenth tolerances, a lot of indicators or bore gauges don't have the sensitivity to transfer the motion to the indicator accurately enough. There's too much stick slip and stuff going on. So I built the ones that you saw there, which every single uh, item through the entire thing, including the centralizing levers and everything, is all on flexures, which basically have no friction. They have hysteresis, but they don't have any friction. Um, and so they're super sensitive. And there's absolutely, the slightest little twitch on the actual change goes directly to the indicator with no lost motion. So I did those out of frustration, and um, that was way back. I did those so far back that that's when we were using our first CAD package where I worked was Hewlett Packard ME10, which was a 2D drafting system, 2D CAD system, and so that was actually done in 2D. Uh, and yeah, I made a couple of those, and they're very handy.
Yeah, I definitely use enough bore gauges to know what you're talking about. They can be a little frustrating for sure. Let's see. Pantechnicon Design asked, over the years, I'm guessing that there were times you considered moving into an industrial building. Can you comment on your choices to stay in the home shop and some of the sacrifices and benefits of that decision?
Um, I've never actually considered going into a shop, basically because I'm a weenie and don't have the nerve or the desire to necessarily have more equipment or have employees other than family. Um, if I was immensely younger, I might consider that now, but and I don't say that I'm not going to stop. I mean, I'm not going to retire. So you know, one of these days, if you guys are still around, you're going to see all of a sudden my YouTube is going to stop and my Instagram's going to stop, and that's when I drop dead in the shop and they just drug me out, and that was it. So
Oh my gosh.
I'm I'm not I'm not gonna I'm not gonna be stopping because of unless I can't work, because I just, why would you stop doing something you love doing and continue contributing to the community? Why would you stop doing that? Uh,
That's a
Too
good
many
point.
people I see that once they stop working, their whole, they just go downhill. There's nothing driving them or interesting them. So why would I stop doing my hobby? It would be silly. So anyhow, the um, that's kind of the reason I don't. Yeah, being frugal and being a weenie as far as jumping out and doing things. I'm much more comfortable with the bootstrap things, and even some of the product things I'm thinking about. It's to the point where I would be smarter to farm out some of the work if things get to a point, and if necessary, do the finer aspects of it. And the other problem is, if I had space, I would just generate even more projects that are hard to complete. So you see some machine like, oh man, that thing's super cheap, and yeah, I'll get that, and end up with 800 things that are never going to get done. So in one sense, the limited space is a very good discipline tool.
Okay, yeah, that totally makes sense. And it sounds like you've got your hands full with some projects anyway. So,
Yeah.
Yoav Rosenbach asked, if you had to build your shop from scratch again with only new machines and thinking budget oriented, what kind of machines would you buy, or what machines would you buy?
Hmm. Wow, budget oriented. I would buy another Harrig grinder. Uh, there's nothing magical about the Harrig, so I don't think that's like the be all end all grinder. except it's a very clean, very simple design. If you want a grinder that's like easy to rebuild, manageable to rebuild, ultra simple. I mean, it just doesn't get any simpler than a Harrod grinder. It's just the parts necessary. Um, and they work good. So and mine's not usual in because of that centerless grinding thing that I mentioned on where that grinder came from. It has a 3 horsepower Pope spindle, so it's not lacking on horsepower and metal removal capability. Um, and so yeah, you can really. I keep forgetting that when I'm barking off material sometimes that and showing people how to get it done on the grinder. Um, that they're not necessarily going to be doing what I'm doing because they got a third of the horsepower typically. But still, it's. I had a lot of comments on my surface grinding videos of like, wow, I never even imagined doing this kind of stuff on a surface grinder, and because some people think of it, oh, just flat surface, that's it, and it's it's a very versatile machine. So it would be a hard grinder. Um, I couldn't do without a Harding tool room lathe, and that's certainly not budget, but uh, it, it's life's not worth living without one. so, so I'd have to have that. Milling machine. I mean, budget. I certainly would. I It's one of those catch-22s. You see all the stuff I can do in my track mill relative to like working on the grinder and stuff just because of the capacities and everything. It's just so handy. And yet the control, I think the newer ones, if I bought a new control for it, there are ones that can do the conversational and end run G code. But that certainly would be, you can't be competitive in a lot of stuff without being able to use CAM and use modern toolpaths and strategies and stuff. But I'd really miss the capacities of the track to get a CNC machine with the amount of Z travel that I have on the track. Number one, it wouldn't even fit in the garage. But yeah, would be a pretty huge normal CNC machine. It might still be a track machine with a new control, but that's not necessarily budget. I don't know what those things run for now, but when I bought mine, it was like $30,000 way back, like 25 years ago. Um, and personally, I would, for what I do, I would buy the Tormach again. Um, I'm not a sales shill for Tormach at all. But I'm very happy with it. I like the control. I like the way it runs, and I do it again.
That's good to know. Most people that I talk to with one seems like they really like it. So
Yeah.
Especially with the clear path servos on it. That's a whole nother animal with that. As far as the speeds and stuff is really, re- really helpful, especially with gang tooling and stuff.
totally.
Let's see here. We're down to a couple now.
Student machinist had two. He said, do you feel that it's worth to take the time out of your day to film and edit informational stuff? And then what makes it worth it to you?
There's tons that I don't film. There's two, at least the way I do it, and I'm no expert. I know that editing to remove all of the every free second is very important. Because if you don't do that, it gives people time to flip to something else or get bored or lose interest. So if they're at all interested in what I'm presenting, I'm not going to give them any excuse to stop. they're not going to have a chance to breathe and look for something else, because I don't want to be any wasted space or pause. I mean, I literally trim. I go through and trim everything. I'll wait and I'll back up, 1 second before my words start at the begin and then at the end. And if there's any pauses in the middle, I'll chop them out. And that takes forever to edit.
I bet. Yeah.
Um, but I think it's very important to what people are used to from me. Um, and So that's one aspect. The other thing is that it makes things takes at least twice as long or more to video them. But I want to share the information. So like the spindle video is one that I did intentionally, knowing, okay, I'm going to do this, but I'm going to literally take every shot as clean as possible to keep the editing down, and do it over and over again there instead of editing forever. So I did that on that, and that worked out well. Um, but what makes it worth it is the comments. Just people that are, just, you know, thrilled about the content. They're inspired. You know, they wish, like the spindle video. I wish I would have seen this earlier, type thing. Um, you know, it's just very. I guess the ones that I like the best are the ones people that are inspired to up their game. Um, and or people that say, "Wow, this looks like, it makes me wish I had chosen this instead of what I'm doing now." That just feels good to know that you're influencing people, making them realize there's other ways to make a living that are insanely rewarding. If people realized how good it feels to envision something and make it and hold it in your hand, it's just nothing better. It's just as you guys well know. Um, it's just a great feeling.
Yeah, for sure. He also asks, have you seen an increase in business or the ability to be more selective of your business since releasing informational videos?
Actually, Instagram is way more influential there than videos.
Interesting.
The Instagram, um, I have two relatively steady customers on Instagram, um, that just got to know me on there, and we shared stuff, and so I get work from them. Those plexiglass pieces, the acrylic pieces that I did, those see-through gizmos that I did on there, that was from a an Instagram friend, and yeah, so yeah, that's definitely worked out, and it's just nice having connections like that to not just business but actual friendships, sharing stuff business wise and all that.
And then, kind of along the same thread, Laney Machine Tech asked, "Why do you pick non-commercial projects?" Well, we've already talked about why you pick the non-commercial projects you work on. So actually, we can skip that one. You pick them as a challenge and to learn something.
Yep.
I think I wrote that right. I don't think he said
Yeah.
commercial. Let me double check. But so yeah, that's
Well, I can make a comment somewhat related to that, in that um, there are uh, there are lots of things. You'll see me make a cutter or something on the D-bit grinder, or even some of the videos like where I made the insert boring bars, or the way that I did the custom groove tools that I made. And you can look at that and say, well, that's nuts. You should be buying those. And yes, in a certain environment, that would absolutely be true. But you also would never develop the skills that you have for being able to make those when it's not a off the shelf item. And those are the things that really hone your skills. It's nice to be able to say, oh, I can't. There is no off the shelf insert holder like that. Well, you could pay somebody to make you one custom, or you can do it yourself. And if you're good at it and have experience at it, you take your hourly rate and everything, and it's no more expensive. So, and there's all kinds of arguments about why that's still not a good business decision. But if you consider the skills that you develop in the process, it's worth it for me. And it doesn't mean that I don't buy cutters, but I enjoy making the cutters, and you can do things that aren't available off the shelf.
Yeah.
Totally. AHM&M asked, will you be finishing the bicycle? And do you still enjoy model making, or have you grown out of it?
I will not be finishing the bicycle. There's aspects of model making that would be fun, but there's so many useful tools that I would like to make to market that I would much rather do that.
That makes sense. And then what about model making?
The project like the tool room spindles is much more enjoyable to me than model making. It's not that there's aspects of model making that wouldn't be fun. I mean, I'd love to make watches. I mean, I'm never going to do that, but I love the all the things that go into that. But it's one of those things that, I know I'm not going to go there because there's other things that, there's a huge learning curve there. Even being a reasonably skilled machinist doesn't mean that you know what's involved in making a watch. Now, I'm learning more and more listening to the watchmakers, not because I want to make a watch, but there's lots of things that are applicable about their techniques and things that are useful. So no, I will never be making a watch, but being able to do watch size parts and that type of thing is nice. You remember the post where I was turning the 1,000th diameter steps starting at 1,000th diameter on the Harding?
Mm-hmm. Yeah.
Yeah, that's an example. I actually, one of my watchmaker friends sent me some of the special steel that they use, and I said, okay, let's see what this stuff does. And I thought, oh, let me see what I can do on the Harding. And there's a case of that's a perfect case of knowing what's important. Number one, insanely sharp tool, which is commonplace for me with the ceramic lap and diamond compound. And you also have to realize, well, how accurate does your center height have to be when you're turning a 1,000th diameter?
Very.
So yeah, that comes into play. But yeah, that's kind of stuff there. But yeah, I'm happy doing the more productive, the metrology and tool maker items. I think I have a lot to add to that whole area. So that's going to be my focus.
Yeah, totally. Well, speaking of metrology, what pieces of metrology equipment do you think that every shop should have, or every machinist should have?
What kind of work do you want to do? What level of work do you want to accomplish?
Let's say I guess we could start with a normal job shop and work our way up to, the kind of precision work that you're doing. Like what do you think that every machinist should have, regardless of work?
A
caliper or something.
An 1.5 face, 5/10 best test indicator, and a same thing 1.5 face, 50 millionths best test indicator, because they are the closest thing to an electronic indicator you're going to get. They are, in my opinion and others, the most sensitive mechanical indicator in existence. A 50 millionths best test can see 10 millionths moves. The needle actually responds to moves that small,
Wow.
and it's also probably one of the lightest contact pressures for that. Um, so some of the other indicators are good, like compact and all these others, but some of them have pretty high gauging pressures, which are a real serious detriment to accurate gauging. Doesn't mean that they can't take good measurements, but um, those are the best indicators, mechanical indicators, in my opinion, of the lever type indicators, and they're the handiest. Um, that a really solid magnetic base. Um, the base that I use, the base that Stefan made a copy of, he will tell you after using those and doing all the things that make them lock up well, lapped fits and all that. It's better than the Nogas in the sense that they're very rigid, they're very quick, and once you're used to them, it just really works well. So if Stefan says, "Hey, I don't even want to touch my Noga anymore after using that style," and it's not like any rocket science there. It's just a good, solid indicator that is going to hold still and adjust well and not rattle around. The flexure style of mount where there's no play, most of the fine adjusts that are out on the indicator end have so much flop around laterally and all that they're just basically junk if you're trying to work to precision. 6-inch Mitutoyo calipers, and
A
not
surface
much you can't do
grinder.
after that. Oh, well, I thought you were talking about metrology tools.
Yeah.
Yeah. I mean, if you want to carry on from there, but in my opinion, I like the Mitutoyo digital mics the best. I think they're hands down the best electronic micrometer. I'm not trying to, you know, uh, downplay any others. Um, but yeah, they just work, and they're crazy accurate, and they're really good. Um, and I typically keep them for my more precise measurements. So I have plain old. I still have my original 1 inch and 1 to 2 Starrett mics from my very first days as a apprentice. I still using them around the shop. So I use those for all the normal work. I don't wear out the faces on the Mitutoyos unless I'm doing something that needs the extra resolution. But as soon as you're talking tenths, I don't even bother with the other mics, and you go right to those, and they save a lot of grief. Um, yeah, I mean that's such a deep thing there. But the 50 millionths best test will show you a lot of things. It's it when I you guys have probably seen my calibrator, my gauge calibrator that measures in two millionth increments.
Mm-hmm.
So that's what lets me actually look at those and say, okay, these things are the best. And then there's a what precision instrument repair. Those guys repair everything, and they agree completely that yes, the Tessa best test Tessa um, um, uh, DTIs are definitely the best. Um, and the other ones work good too. But if you're out for real ultra sensitivity, there's nothing more sensitive to them. And like I said, that lets you get to the. If you're looking really close, you can literally see minor jiggles when people that are looking at the things and saying, okay, yeah, no indicator movement. A lot of that's just sometimes because the gauging pressure is so high that it just damps out everything, and the actual sensitivity isn't good enough that the whole indicator stand and everything is flexing. So the part's moving, but the indicator isn't sensitive enough to respond to it.
That makes sense. Yeah, totally.
And then let's see. Danny Rudolph asks, "Why do the most talented machinists live in Lancaster?"
Oh, that's funny. Yeah, you realize he's within he's only about maybe 40 minutes from me, if that. So
That's all on the back
That's why we
right there.
we asked that one last, Danny, just for you.
Yeah, and yeah, Danny's a very talented guy. I've been there, and very impressive operation, and um, he makes me feel good in that it's somebody else who has room to move between the machines as long as he turns sideways to shuffle through.
Yeah.
Yeah, he does really impressive work there. Just amazing stuff, and yeah, amazing to see. A great attitude about business in general, family, and the whole thing, and staying out of debt as much as possible, and yeah, really good guy.
So I think that wraps it up. I did have one more question for you, and that is, we have all these guests on, and I think it's important to talk about the future of not only machining but the community that we're building and whatnot. Is there anything that you wish you were told when you were getting into this, or something you want to pass along that everyone that's listening should know about? Just any tips or tricks, or a philosophy, or anything you can think of.
Uh, don't wait for the place you work to provide the challenges that you need for the direction you want to go. I realize that if you don't have access to other equipment or things, or they won't let you do side projects, but whatever it is that you wish you were doing, if you like the place you're working, but there's things that you want to get better at, is make a project or whatever to do that. Pick something that you need to do to, or even if it's just to learn the skill. Um, like just like I did with the surface plates. Buy three surface plates and have at it. And take the time required to do what you need to do there, and read up whatever. But don't don't wait for someone to um, hand you on a silver platter the things that you'd like to learn to do. You may have to generate them on your own, and that would probably be my main my main thing. That's just off the top of my head, but that's the first thing that comes to mind
Okay.
as being a biggie.
Yeah, makes
I
sense.
think that's a great one.
Yeah.
Yeah, I've always been a big proponent of side projects and doing projects to learn things, because that's how I learned more than anything. So I'm right there with you.
If no one's gonna teach it to
Yeah,
you,
just
just do it yourself.
yeah, yeah. And you're more or less doing that, Peyton, with your injection molds.
Yeah, that's true.
You just go and say, okay, I want to mold this, and learn how to do some, and get some input from people that give you some guidance, and have at it, and just there's nothing like actually doing it to learn. You can study all you want, uh, and just like you, Dylan, with the 3D printer things, and making the additions. There's tons of stuff that you're learning there in the process. That's doing these tweaks and things isn't it has value. It's problems you're solving. It's things you're learning. It's you're learning all these intricacies of what's makes 3D printing work or not work, and those are all skills that or will translate into other things. And yeah, everything like that is helpful.
Yeah, for
Totally.
sure.
Yeah. I used to have people all the time that would ask me why I'd participate in like the Fusion Cam challenges and stuff. They'd say, "Oh, why aren't you making parts?" And it's like, well, because I can screw around with 3D toolpaths on these parts. I can't do that on customer parts. I just need to get them done.
Right.
So yeah, I've always, like I said, been a really big fan of taking the time to learn something through a project. I could completely uh, empathize and resonate with that philosophy.
Yeah, and the other thing is I would say there's, I don't know, I'm trying to think how to say this well. Try to learn things, not as too many people, I think, get trained to do things as a machinist or whatever, and they get locked into, this is the way to do it because that's what I was told. Okay, that's where their thinking on the topic stops. This is the way you do this operation. I've learned that. I'm done. Move on to the next thing. As opposed to, this is the way this person told me to do it, and there may be a better way, and don't be afraid to experiment with other ways. And in one sense, I think it's better that I didn't have formal training in tool and die stuff or grinding or whatever. It was, seat of the pants, do it, and have a learning attitude as you're doing it, and basically you never stop learning. I mean, every time I go to the surface grinder, it's not like, oh, I know this exact thing. Every time I'm running the surface grinder, I'm thinking about the way that I dressed, how the wheel's behaving, what's going on, and of course I have it down to where I can have it working well. But it's never like, oh, this is the way. I'm always ready to try a different wheel, different approach, um, different ways of doing it, and having that more experimental. The things that were taught were guidelines. I am allowed to color outside the lines if I want to. and don't think of it as, well, this is the way I was taught and that's it. One of the things that amazes me is on the solid tool post video, people say, well, how do you thread now? And it's like, you put the tool in the lathe and you turn it on, you thread just like any other time. 29 degrees is not, or 30 degrees or 29 and a half is a way to do it. It's not the only way to do it, and it has advantages, but you're not going to have any trouble cutting threads direct in feed until you get up into pretty large pitch sizes. And so that's one of those things that just amazes me, that people get locked into, this is it. I read this in the book, this is the way it is, and there's no leeway. If I cut a thread, I must put my compound on 29 degrees, and that's the only way you can do it. And that's sad. And I'm not trying to beat anybody up. I'm just saying that don't get stuck there. Yes, use that as a guideline, but if you have to feed it in straight, well, is anything going to happen? Is the lathe going to blow up? No. Okay, well, let's try it, and go for it. And so yeah, that's my advice.
Awesome. Well, we appreciate you coming on. Is there anything you want to plug other than your Instagram's just Robin Renzetti, isn't it?
Yep.
Okay, cool.
Yep. And Rob Renz on YouTube. And no, just thank you to all my subscribers and on YouTube and followers on Instagram. Appreciate it. One thing I will say, just as on Instagram, sometimes I wonder if you get a lot of comments, and you could spend all day doing actual thank yous and everything, but I do make sure that I give a heart to every comment that I get. So I do read every comment, and I do appreciate them all. Occasionally I'll write something more, and I don't always do the most verbose thing, but I typically do my thumbs up, whatever it is, my 3 characters that I put there to let you know that I did come see this, and I appreciate it. So it's just a matter of not letting Instagram be too much of a drain in keeping up. Because if I'm going to subscribe to you, I'm going to look at what you're doing.
Yeah.
And I'm not going to just subscribe to say, oh, I subscribe, and then just flip through them all, and I'm going to comment. And the other thing is if I drop you from being a follower, it's because you're posting too much. And I'm serious. And I'm not here to tell people what they should be doing on Instagram. But for me, if you post too much, you are running the risk of getting unfollowed, because I don't want to go through 10 things in a day, unless they're all like, whoa, that's interesting, then I'm okay with that. But if it's just 10, generic things for post count or whatever, I'm going to dump you. And I'm not saying that to be mean. I'm just saying it to don't be offended by it if that happens to you. Because it's more important for me to spend my time posting things than it is to keeping up. So I keep a pretty small number of people that I follow. So, yeah, that's about all I have there. And thank you to everybody for your incredible support in both arenas. And thanks for having me on.
Oh,
course.
thank you so much for taking the time. We really appreciate it, and I know I definitely learned a lot. And I've got maybe 10 tabs open now of
I
videos
know,
to watch,
same.
books to look at, and all kinds of stuff. So, thank you again for coming on and taking the time.
Yeah, not a problem. Appreciate it, you guys. Thanks.